Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 3, Chemical Foundations, Part 3. Here are our objectives for today's video. We are going to continue with significant figures and application of significant figures. Pause here. So sometimes in a lab, you will need to add or subtract measurements, and we have procedures for significant figures with doing so, such that number one, everybody is consistent when we are doing experiments, and number two, such that we don't create precision where we don't have it, because it is possible that one of the measurements came from a device that was more precise than the others. So that is why we have these rules. So I'm going to show you this with an example. So you line up the values. You might not have to do it this way every single time, but for now, you're going to want to line up the values. You're going to perform the calculation ignoring significant figures. So here I get 4.50. And now we're going to round to the most precise digit on the least precise measurement. So I'll show you what that means. So the most precise digit is just a digit all the way to the right. So in the 4.00, it's the second zero. And on the 0.5, it is the 5. My least precise measurement is just the one that is further to the left. So my 0.5 is my least precise measurement. So now I round to the most precise digit on the least precise measurement, which means I need to round to the 10th place. So when I perform this calculation, my final answer here is 4.5. All right, let's take a look at a couple more examples. You don't necessarily need to draw it out like this every single time. I did so such that you could see it. But as you're first getting used to it, it's not a bad idea to continuously write them out. Pause here and take a moment to try it. We've already done the first one. So for the first one, we already know our answer is going to be 4.5. We're just going to make sure that we include the unit in there. So this is 4.5 milliliters. So for our second one, you initially get 4.5, but you have to round it to your nearest 1. So you end up with 5 milliliters. So when you first put this in your calculator, you get 440, or you could probably do this one in your head, you get 440 milliliters. But I have to round this to the nearest 100. So it actually just becomes 400 milliliters. So I initially get 440 milliliters, and I need to round to the nearest 10. So 440 is actually just fine as it is. So I leave it at 440 milliliters. Pause here. So multiplication and division is a little bit easier than addition subtraction. So if you are multiplying or dividing, it does not matter. Even if you're multiplying 10 different numbers, you just round to whatever the lowest number of significant figures in the measurements are. So if one of your values has 6 sig figs and the other has 1 sig fig, you round your final answer to 1 significant figure. If you have one that has 9 and one that has 3, you round to 3 sig figs. So it's just the lowest number of significant figures. Pause here. So this 4.5 has 2 sig figs and 5 has 1 sig fig. So I round to 1 sig fig. So 0.9 is all I need here. And then I have to make sure that my units are correct. So grams/milliliters. So here I want 2 sig figs because both 4.5 and 5.0 have 2 sig figs. So I actually have to add a 0 here to make it significant. And for both the first one and the second one, I could have left off the 0 at the beginning. It is only personal preference if you want to include it or not. So 4.5 has 2 sig figs and 5.440 has 4. So I put it in my calculator. I originally got 24.48, but I need to round this to two significant figures, so it's just 24. And then the final unit here is meters, since the seconds on the bottom cancel with the seconds, so I'm just left with 24 meters. Right, that is all for today. Thank you so much for watching and have a great night.